Hello everybody, so this is again Dr. Sergey Sargasov, and today we'll focus on trigonometric angle formulas. And I specifically want to derive this right here. What in the world is sine, the sum of angle formulas, sine of alpha plus beta equals to what? That's a really cool question, and what I'm going to do is I'm going to use a visual unit circle proof, which is insightful and rather tricky. I encourage you, after this video, try it on your own. It's kind of tough. Even when you see it, sometimes later on, I even sometimes make a mistake and forget how to do it myself. And it takes me some time to visualize and think and, receive it backwards to proving it for myself and then showing it to you. So anyway, let me show you this. Let's go ahead and draw a unit circle. Now we have to know the fundamentals of trigonometry, right? The sine, cosine, tangent, cotangent, secant, cosecant. What are those in general? How they relate in the right triangle trigonometry context. For example, sine of alpha would be, if you have an angle alpha here in a right triangle, right here, this is an opposite side, opposite over hypotenuse is sine. Cosine is adjacent over hypotenuse, right? So those things we have to know coming into this presentation. Anyway, in a unit circle, what is that? That means for every point on that circle, let's say we have a circle, the point right there will be cosine of this angle, comma sine of the angle. The x value is a cosine, the y value is a sine for a unit circle. Okay, radius r equals 1. So let's draw a unit circle. Derivation of this. I'm going to do unit circle. So here's what we're going to do. I'm going to say, you know what? Let me have the y-axis here, okay? And the x-axis, I'm going to make it kind of more quadrant 1 oriented, right? So it's easier to see what's going on. And positive numbers are just easier for us to use. Let's call this x-axis, of course. And let's say this is 1. I'm going to make a big old unit circle where I'm going to say, you know what? I'm going to do this. I'm going to make a unit circle that's kind of looks like a circle somehow. Okay, somehow kind of quarter circle, and it goes on and on and on. And so left, 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 left also, right? But so we're going to focus specifically on the kind of quadrant 1 area, where I'm going to say, you know what? Let's say this is angle alpha, right there. Okay, angle alpha. And then, you know what? If we're talking about alpha plus beta, might as well draw a beta angle. Okay, let's say this is angle beta. Okay. All right, now what? Well, yeah, we know unit circle, so this is going to be what? The point's going to be cosine of the angle alpha, sine of the angle alpha, right? For this angle alpha, this point in the unit circle, radius is 1, corresponds to, and this is also radius 1, corresponds to cosine alpha, sine alpha. And what is this point? Hint, it's not sine beta or cosine beta anything. This whole angle is alpha plus beta, so this point's going to be cosine alpha plus beta, okay? That big angle is alpha plus beta, sine of alpha plus beta. And that's where we see this right here. We see that, we're like, hey, that's what I want to know. Now that means what? That's the y value. That's right there. I want to know all of this height. How do I find that height? And here's a trick we're going to do. First of all, we did not do anything with cosine beta and sine beta yet, right? So take this, you see this beta? And I'm going to make this this is the hypotenuse. Let me project from there onto this base right here. Right there, make a little projection, make a right angle here. And you see what's going to happen is this right triangle with hypotenuse 1 and angle beta right there, with the 3 vertices here, there, and there, okay? This will be sine beta. This will be cosine beta. Cool, right? Let me even write that. Sine beta here, okay? And then this is going to be from there to there, cosine beta, okay? So let's see what we can do with this information, okay? What we can do with this information, basically, is, let me do one more thing. I'm going to kind of partition it right here. I'm going to do that. That'll help me a lot. It's a little trick here, okay? Let's kind of do a little horizontal line there, okay? A little cut there. All right, now, you see this right here? Let's kind of go to another marker, okay? So this is, let's say, from here to here. That's going to be our y1. And we want this y1 and then another y2. Okay? If we can find y1 plus y2, we find this sine alpha plus beta. Okay? Cool. So y1, what in the world's y1? Well, y1, you see this? Now, here's a trick. This is alpha. I'm going to verbally tell you. Okay? So this is alpha. So this is 90 degrees. So this is what? This is 90 minus alpha. Vertical angles, that means this is 90 minus alpha. Okay. And this is 90. So this is going to be alpha as well. Okay. This angle alpha as well. Make sure you notice that. So this angle alpha, this is angle alpha. There's a reasoning why that I gave you now. And you see, let's try to do, ready? Let's try to do cosine. What in the world is cosine of alpha? What is it? Let's look at this triangle right here, this right triangle, right over here. Cosine of alpha, let me talk about this triangle here, okay, is adjacent over hypotenuse. That's going to be y1 over sine beta. y1 over sine beta is equal to cosine alpha. And so we have found that y1 in terms of alpha and beta is cosine alpha sine beta. All right, we got y1 out of the way. How do we find y2? Well, y2 here is the same thing as y2 right there. You see, this is a very tricky argument, very insightful, very clever, creative, whatnot. And if you do it in the wrong direction, wrong way, wrong segment, wrong projection, it's going to be tough to make it work. Okay, so this is also y2. Now, let me see what we can do with this. Well, think about this. Right here, let's do this in kind of blue, from here to there, remember I told you, from this point to this point, let's even draw that. It's going to not to mess up the diagram too much, but this is going to be from here all the way to here. What is that? That's going to be cosine beta. Remember that? See that? Cosine beta. This is sine beta, this is cosine beta, okay? So this is going to be this kind of this line right here. That's going to be, that length is going to be cosine beta, okay? Now that's cosine beta. We're looking for y2. What in the world is, ready, let's do this. What is y2 divided by what we said, cosine beta? Okay. Opposite over hypotenuse, the angle is alpha, sine alpha. There we have it, sine alpha. And we solve by multiply both sides by cosine beta, solve for y2. y2 is equal to sine alpha cosine beta. We have we almost have proven this awesome result, that what in the world, let's do this here, so y1 plus y2, sine alpha plus beta, which is exactly the y1 plus y2, right? Is equal to what? y1 and y2, let's do y2 first actually, just the ordering. Sine alpha cosine beta, and then plus the y1 was a sine beta, or what is a cosine alpha? Sine beta. Cool, right? We've proven that result. In fact, you could do the co-function identity to go for cosine. Remember? Cosine of, what is sine? It's a 90 degrees minus. Cosine of the 90 minus the angle, right? So if you did, for example, cosine alpha plus beta, you could do, it's sine of 90 degrees minus alpha minus beta, and then group those together, and you would get a similar formula. But we're going to do this directly from the picture. So the question is now, let's do this other kind of question that I would put here. The other one we would have been doing would be, what is cosine of alpha plus beta? Let's do that as well, that argument, so you can see how to do this. And this can go a little more quickly now. So what we can do is, let's prove this kind of in green, with the blue kind of still drawing pictures. So what is cosine alpha plus beta? Well, that's going to be the x stuff, right? Cosine alpha plus beta is going to be right over here. From here, that's to what? That's to cosine alpha plus beta, let's call it. To this right here, right? That's cosine alpha plus beta, the x value there. Okay. Cool, right? Okay, well, what do we do there? There's probably some minusing going on, because look, this right here, let's do this from this point, from the origin to that point, what in the world is that? Let's call this right here, let's call this all this x1, okay? See that, everyone? And then probably, what are we going to do? We're going to call this x2, okay? And we're going to do x1 minus x2 to get this green thing, right? This minus that will be that. Well, what is x1? x1 is equal to what? Let's see. if we do x1 over the hypotenuse, see that? x1 over the hypotenuse there, so the adjacent hypotenuse, that's going to be cosine alpha, right? Cosine of this angle is this over that, adjacent hypotenuse for that triangle. Okay, so cosine, so what is it? x1 over, what we call this to be, what is that? Cosine beta, remember? That's cosine beta. You see that squiggly one? Over cosine beta is exactly equal to, let me write it a little neater here, cosine alpha. Cool, right? I think this is a little easier. The horizontal one's a little bit easier than even the vertical that we did for this. This was a little tougher, I think. Okay. So anyway, we have x1 is equal to cosine alpha, cosine beta, if you can see that, right? Okay. What about x2? x2, see that? Is that right there? How do we do that? Well, now, let's see what we can do here. This x2, right? You see this is sine beta. And this is, what is that? So x2 is right here. And let's do, what is sine alpha, this angle alpha? It's opposite over hypotenuse. See this right triangle? It's going to be opposite over hypotenuse. So sine alpha is going to be opposite, which is x2, over hypotenuse, which is sine beta. And we get what? That x2 is equal to sine alpha, sine beta. And some of you already know the formula, so then you're like, oh, okay, I got this, I know what it's going to be. And so look, what is x1 minus x2? x1 minus x2, right, is going to be, or let me change it to purple. So x1, the big x value minus the little one, right, this minus that is going to be the green, is equal to cosine of alpha plus beta. So alpha plus beta, the cosine decreases, right, because it goes from 1 all the way, like as you're increasing angle from 0 to pi over 2 radians or 0 to 90 degrees, it goes from whole 1 horizontal to just a 0 horizontal, right? Okay. So anyway, this is equal to, let's put this here, and we get x1 is what? Cosine alpha, cosine beta, and then minus that sine alpha, sine beta. Cool, right? And so that is how we get these formulas. Right here, the big formula, and right there. Right? Hopefully that was very cool and insightful and helpful, and I think you really may have enjoyed that. As an additional bonus, I know sometimes we kind of want those little bonuses. Let me show you something really cool we can do. What if you're interested, you know what? I have no idea, but how do you find sine of maybe 75 degrees? All right. Because that's an angle we can do without a calculator, turns out, in a more like a, how to say, more, what is it? I'll get a formula for that number, right? You can actually get a, not just an applicable number, not just kind of a decimal number approximation, but an exact, right, kind of transcendental result. Not really transcendental, but okay. So what happens is we can do this. Let's do sine of, let's just try one example, sine of 75 degrees. And the trick to doing that is, you know, 45 degree stuff, you know, 30 degree stuff, right? So I'm just going to rush this a little bit just to give you some kind of trick to why these formulas can be helpful. So it's that plus that, right? Is that true? Yes, it's true. You could do that in radians as well. I think degrees is a little bit easier. And then we do what? We apply the formula. Sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So let's write this, okay, as sine of alpha, the first angle is 30 degrees. We know what that is. Cosine of 45 degrees, the second angle, plus cosine of the first angle, 30 degrees, sine of the second angle, 45 degrees. Let me see if that's fitting on the board. It is. And then now look, that's a 1/2, right? That's what cosine 45 degrees is root 2 over 2. We better know all these. And then what is this? Plus a root 3 over 2 cosine 30 plus a root times a root 2 over 2 for sine of 45. And that's going to be, ultimately, you can write that as a root 2 plus a root 6 over 4. And yeah, that's kind of messy, but it's what it is. And mathematicians like this result much more than the calculator number. So hopefully that was really cool. I think you may have learned a lot from this lesson. Again, this can be done for a lot of other formulas in a much easier fashion. I think especially what we did here initially, and the red and finding that formula, is a tougher way than I would usually do to proving the sine alpha plus beta. And you may wonder, hey, how else can you do it? I encourage you to try this is a little hint, okay? I'm going to call this class in a bit. But try this thing. What is area formula? And then for a triangle, have this angle alpha, have this angle beta. Just a little heads up, try this. It's another formulation for proving sine of alpha plus beta. And if you do perpendicular here, okay, and you find the area of this triangle, you see the right triangles, by the way. But you do, remember, the area of a triangle is 1/2 side, side, sine of the angle between them. And so you can do this, and you can do that, and you can do the sine alpha plus beta together for the area of the whole triangle. Guess what? It will give you the same formula. I think this is a little bit of an easier approach, but I want you to try it on your own from a few things that I've mentioned. And I know there may be confusion, that's not enough said. Okay? All right? Hopefully you enjoyed that. Have a great remainder of the day. Feel free to comment. Let me know if you want to see anything else. And let's see. I'm going to stop the video here.